The moon has captivated humanity throughout history, inspiring mythological stories in nearly every culture. In this article, we will examine the different phases of the moon, its lunar orbit, and the influence of the moon's gravity on Earth. Like clockwork, the full moon appears monthly on our sky, a familiar sight often taken for granted. However, approximately twice a year over the few hours, the full moon takes on a noticeably different appearance. This change is caused by a lunar eclipse, which occurs when the moon passes through Earth's shadow. Similarly, a solar eclipse happens when part of Earth passes through the moon's shadow. Although the moon completes its orbit around Earth every month and aligns at both full and new moon phases, eclipses do not occur twice monthly. This is because the moon's orbit is tilted relative to the Earth's orbit around the sun. Despite the long shadows cast by Earth and the moon, they rarely overlap due to this orbital tilt. Yet, about twice a year, the moon's orbital tilt aligns with the sun, allowing it to pass through Earth's shadow and cause a lunar eclipse. As the moon moves into Earth's central shadow, called the Umbra, it darkens significantly and appears dim red due to sunlight scattered through Earth's atmosphere. A solar eclipse occurs when the moon positions itself between the sun and the earth, with only a narrow band on Earth experiencing a total eclipse as the moon's shadow moves across the planet's surface. Observing the moon over several weeks reveals subtle daily changes in its appearance caused by shifting shadows as it orbits the earth. This cycle, known as phases of the moon, repeats roughly every month. However, at least twice a year, the moon passes through Earth's shadow, causing it to darken and turn a deep red briefly, a phenomenon called a lunar eclipse. From space, the eclipse begins as the moon enters the Penumbra, where sunlight is only partially blocked, causing the slight darkening. As it continues, the moon enters the Umbra when all direct sunlight is blocked. Despite this, the moon turns red because sunlight passing through Earth's thick atmosphere scatters shorter wavelengths like blue, leaving longer red wavelengths to illuminate the moon. On Earth, this is similar to the reddish hues seen at sunset. As the eclipse ends, the moon exits the Umbra and Penumbra, brightening and returning to its usual cycle. On September 27, 2015, a rare astronomical event called a supermoon lunar eclipse occurred. A supermoon happens when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit, making it appear up to 14% larger in diameter. When combined with a lunar eclipse where the moon passes directly behind the earth into its shadow, acquiring a red tint, this event becomes particularly special. Since 1900, only 5 supermoon lunar eclipses have occurred. The last one before 2015 was in 1982, and the next one will not take place until 2033. Regarding the moon's phases, it takes approximately 27.3 days for the moon to complete one orbit around Earth. However, an additional 2 days are needed for Earth to realign with the Sun, making the full cycle about 29.5 days. During this time, the moon rotates once on its axis, which explains why only one side of the moon is visible from Earth. The moon's gravity causes ocean tides, making water levels rise and fall depending on the moon's position. When the sun, moon and earth align during new and full moons, their combined gravitational pull creates higher high tides and lower low tides known as spring tides, resulting in a greater tidal range. Conversely, during the first and third quarters, when the sun and moon are at right angles relative to earth, the sun's gravity partially counteracts the moon's pull, producing neap tides with smaller tidal ranges. Approximately every 24 hours and 50 minutes, Earth experiences 2 high tides and 2 low tides, with about 6 hours and 13 minutes between each tide, a pattern called semi-diurnal tides. Various tidal effects occur worldwide, and understanding tides is crucial for mariners to plan navigation and port access. For further information, the Earth Rocks YouTube channel is highly recommended for students interested in earth science.